Okay, so welcome back, class. We will continue with the second subtopic, okay, 3.2, Ohm's law and resistivity. Okay, so Ohm's law state that the potential difference across the metallic conductor is proportional to the current, okay, flowing through it if its temperature is constant. So we can write as V equals to IR. Okay, so this is Ohm's law. Okay, so we define as the potential difference across the metallic conductor is proportional to the current, okay, flowing through. Okay, so this is the equations when we say Ohm's law, meaning that V equals to IR. Okay, next. Okay, figure shows that the potential difference V against current I graph. Okay, so because it's directly proportional, so you will get a linear graph, okay, where the gradient here is equal to the resistance. Okay, the gradient for V versus, okay, V over I, gradient for V over I actually is equal to our resistor. Okay, or we can write as V equals to IR. Okay, where your R here is the gradient. Okay, later in our experiment, okay, you will do this experiment to determine the value for the resistor. Okay, we continue with page 59. Okay, after you learn the Ohm's law, okay, we will go to a resistor. So a resistor is the ratio of potential difference across the electrical component to the current passing through it. So our V equals to IR, meaning that your R is equal to V over I. Okay? V over I, because V equals to IR. Okay, so we say resistor is the ratio of potential difference across the electrical component to the current passing through it. Okay, so R equals to V over I. I is the current. And it's a measure of component oppositions to the flow of the electric charge. So it's a measurement of the component oppositions of the flow of the electric charge. Meaning that if the resistor high, okay, the current will flow slower. Okay, dia macam satu halangan. Okay, if the resistor high, meaning that your current flow will become less. Okay, R here is the opposition. Dia macam satu halangan. Okay, macam satu halangan. Okay, halangan. Okay, so if the resistor tinggi, bermaksud halangan dia tinggi. So current nak melalui susah sikit lah. Okay, so we continue. Okay, the resistor is a scalar quantity as well, so we don't need to consider the directions. And we can write it as ohm. Okay, ohms. Okay, or we can write volt per ampere. But usually we use ohm. So this is a symbol. If the temperature of the metallic conductor is constant, hence the resistor also constant. Okay, so if let's say the current is constant, meaning that your resistor is also directly proportional to the temperature. Okay, so meaning that if the temperature increase, your resistor also will increase. Okay, because your resistor is depends on the temperature. Okay. Okay, next we go to resistivity. Okay, so resistivity is defined as the resistance of the unit cross-sectional area. Okay, it's the resistance of a unit cross-sectional area per unit length. Okay, per unit length. So we can write it as equations. Resistivity, okay, is equals to RA over length. Okay, over length. Okay, meaning that this is a scalar quantity. This is a scalar quantity. Okay, it's a scalar quantity, and because it is a ohm area per length, so our unit for resistivity is ohm meter. Okay, ohm meter. Okay, what is the meaning of resistivity? Okay, So resistivity is a measure of the material's ability to oppose the flow of the electric current. Okay, so it's a one kind of ability. Okay, sama ada dia mampu untuk menghalang ataupun dia tak mampu. Okay, so it's the ability to oppose the flow of the electric current. So meaning that similar like resistor, if the resistor high, meaning that your ability also higher. Okay, if a resistor is higher, meaning that the ability to oppose the flow of the electric current also will high. Okay, so the resistivity is depends on the type of the material and also the temperature. Okay, so if let's say the questions asked in objective resistivity, it depends on the type of the material. Okay, and also it depends on the temperature. Okay, if the temperature increase, your resistivity also increase. Okay, a good electric conductor have a very low resistivity. If let's say this is a conductor, it has a very low resistivity. If it is an isolator, it will have a very high resistivity. Okay, meaning that if let's say for a conductor, the current is easier to flow. Okay, so this one resistivity high. Okay, resistivity high makes meaning that it is an isolator. Okay, meaning that the current is difficult to flow. If the resistivity is low, meaning that it is a conductor. Okay, meaning that the current is easier to flowing through. Okay, so this is the depends on the material. Okay, and usually conductor is a metal. It's a metal. It's a conductor. So meaning that the resistivity is very low. Okay, because current can flowing through easily. Okay, if let's say isolator, for example, let's say a paper, okay, is an isolator. Okay, or a glass is an isolator. So when it's isolator, the current is not easily to flow in. That's why our resistivity is high. Okay. Okay, from the equations, resistivity equals to RA over L. So therefore, the resistance of the conductor, it depends on the length and also the cross-sectional area as well. Okay, it depends on the length and also cross-sectional as well. Okay, meaning that if let's say you want to have a high resistivity, your area must be larger, but your length must be smaller. Okay, or shorter. Okay. Okay, G table shows the resistivity of various materials. Okay, so if you just now we already mentioned, okay, if let's say a conductor, your resistivity is very low. If let's say for a conductor, okay, because the current is easily to flow. So if you refer here, silver, copper, aluminium, and also gold, okay, all these material is actually a metal. Okay, so it's a conductor. Okay, and the resistivity, if you look at here, is power of -8. Power of -8. Okay, meaning that this four material, the current will flow passing through very fast because it is an conductor. Okay, it's an conductor and the resistivity is very low. Okay, whereas for a glass is power of 10 to power of 14. Okay, so this one is actually an isolator. Okay, it's isolator. Okay, so when it's isolator, your resistivity is very high, meaning that the current is not easily passing through. Okay, so we look at the example 3. Example 3. So when a potential difference of 240 volt is applied, okay, across the wire that is 200 cm long. So this is the length. So we convert it to 2 meter. And then this is the potential difference V. The current per unit area. So the current per unit area is 7.14 times 10 to the power of 9 ampere per meter square. Okay, calculate the resistivity. Okay, calculate the resistivity. So resistivity equations is equals to R A over length. Okay, but we don't have R, but we know that R, okay, equals to V over I. So we substitute inside, we change to R, we change it to V over I. And then AL. Okay, we change R, become V over I. Okay, so next, we substitute the value. Okay, V is 240. Area we don't have. Current we don't have, but we have the length. We have length. Length is 2 meter. Okay, so from A over I, okay, just now we have I over A. Okay, so it's 1 over 7.14 times 10 to the power of 9. Because they want area over I, not I over area. So we write 1 over 7.14 times 10 to the power of 9. So if you press calculator, you will get 1.68 times 10 to the power of negative 8. Okay, and the unit is ohm meter. Okay, ohm meter. Okay. Okay, so your homework is example 4. Okay, example 4. Okay, maybe we can go through a little bit. So two wire PQ with the circular cross-sectional area are in the same metal. Okay, when we say same metal, meaning that your resistivity, okay, your resistivity, rho 1 is equal to rho 2, resistivity, and have the equal length, equal length. Okay, so when we say equal length meaning that your L1 will equal to L2. If the resistor of P is 3 times, so resistor of P is equal to 3 times of resistor of Q. Determine the ratio of their diameter. Okay, so from here, RP equals to RQ. Okay, so you can derive R, okay, rho equals to RA over L. So our R is equals to rho L over A. Okay, is equals to 3 rho L over A. Okay, so this is 1, 1, 1. This is 2, 2, 2. Okay, so since rho resistivity for both same, length for both also same. Okay, so you find the ratio. You want to find the diameter. 1 over diameter 2. Okay, so you find out what is the answer. Okay, so that's all for today. Example 4 is your homework. So remember to send in to your Google Classroom. Okay, thank you, class. We will continue with the next subtopic.